everyone, this is the video for Algebra Section 8, Algebraic Fractions. In this video I'll give an overview of the topic, I'll then go through the worksheet and finally I'll answer the questions that are on the worksheet. You probably know the drill by now. In the description box below there is a link to my Instagram account. Here you can find images of the worksheet and the answers pages so you can copy from them or take a screenshot, things like that. Right, algebraic fractions. The bad news is fractions aren't just reserved to numbers. It appears that there are letters involved these days, but silver lining, the same rules still apply even when letters are in fractions. If you want to add a fraction that has letters, you can use the same rules that you know from when the fraction just contained numbers. Again, for subtracting. Similarly, multiplying. If you want to multiply algebraic fractions, remember, you multiply the numerators and you multiply the denominators together. And dividing. I love this rule with dividing fractions. If you have a fraction and you want to divide it by another fraction, all you do is take that last fraction, flip it, and change it to a multiplication problem. Love it. So you know this topic, it just looks a little different, i.e. instead of numbers, you've got some letters as well. Let's just go through the topic and you'll see it's fine, and then you can test it out with the examples at the end.
Right, this is the worksheet for Algebra Section 8, Algebraic Fractions. Like I said, there's nothing different between algebraic fractions and normal fractions other than algebraic fractions just happen to have some letters in them. But you don't have to take my word for it, so what we'll do is we'll go through some examples of how to add and subtract algebraic fractions, as well as multiply and divide algebraic fractions, and you'll see that the rules that you use when the fractions just contain numbers are the same as the rules that you'll use for when the fractions contain letters, i.e. they're algebraic fractions. So let's start with add and subtract. To add two fractions together, the denominator must be the same on both fractions. The denominator is the bottom number here in the fraction. So this example here, the denominator is the same, so we can just go ahead and add these two together without doing any kind of manipulation. 1 over a plus 1 over a becomes 1 plus 1 over a, which then equals 2 over a. So here you've added an algebraic fraction and the rules that you already know for numeric fractions still holds. What about this second example? Here we have minus 5 over b plus 3 over b. Again, the denominator in both these fractions is the same. We have b's, so we don't have to do any form of manipulating. Therefore, this becomes minus 5 plus 3 over b, which then becomes minus 2 over b. What about a third example where the denominator isn't the same? So here we have 2 over a plus 1 over 2b. The way to get the denominator the same on these two fractions is to have 2b over here, so we have 2ab, and to have an a over here, so again we have 2ab. So how do we get a 2b over here and an a over there? Well, what we do is for this side we times the bottom by 2b and we times the top by 2b. What you do to the bottom you have to do to the top. And this side, to get 2ab on the bottom here, you have to times the bottom by a and the top by a. What you do to the bottom, you have to do to the top. So here it is. We have a times by 2b, so we've got this 2b now over here, and what we've done to the bottom we have to do to the top, so we've got 2b on the top. This side we wanted a over here, so we've times the bottom by a and we've times the top by a. These two fractions now look like this. So here we have 4b over 2ab and we have a over 2ab. Now the denominators are the same, so we can add these fractions. Adding these fractions gives 4b plus a over 2ab. So just like with numeric fractions, in order to add fractions that have different denominators, we need to make them the same. The question you have to ask yourself is, what is missing from this denominator that is in this denominator? Well, that was 2b. And what's missing from this denominator that's in this denominator? Well, that was a. Notice that this fraction here is the same still as this fraction here, but we've got these extra 2b's there. Now these 2b's actually cancel out, if you see, so what you actually have here is 1, so that's 2 times by 1 over a times by 1, which is 2 over a. These can be thought of as almost like dummy manipulations. They equal 1, but We put them in because they help us add these fractions together. So that's adding and subtracting. Same rules, we're just dealing with letters as well as numbers in fractions. What about multiplying and dividing? Let's look at this example here, example 1. We have 1 over a times by 1 over b. The rules for multiplying fractions is the following. We times the denominators together and the answer becomes our denominator on our new fraction. We times the numerators together and the answer becomes our numerator on our new fraction. Sometimes I like to write these times lines. So here, so I remember I'm timesing the denominators together and the numerators together. This becomes 1 times 1 for the numerator and a times b for the denominator, which can be written as 1 over ab. Right, second example. We have 2 over a divided by b over 4. Just like with numeric fractions, when we see a division here, what we do is we change this division to a times and we flip this latter fraction around. So this example can be written as 2 divided by a times by 4 over b. So here the division has changed to a times, this 4 has become the numerator and this b has become the denominator. Now we know how to deal with this. This is easy. We times the numerators together and then we times the denominators together. Here's our lines to show that, and this becomes 2 times by 4 over a times by b, which can be written as a over ab. Right, third example. We've got a combination of multiplication and division. The thing that I like to deal with first is the division. We can easily change this and get it into multiplication and then we can go from there. So here we go. This can be changed, so we have times by 2 over c. Now we know how to deal with these. This is easy. Remember, we multiply the numerators together and then the denominators. The lines here show this. This then becomes the following. We have bracketed a plus 1 times by minus b times by 2. And that is all over b times by bracketed b plus 1 times by c. So the answer is minus 2b brackets a plus 1 all over bc brackets b plus 1. Now, although we've worked this out here, we've got these fractions and we've written it as one single fraction. There is one more step we can do, and that is to get this fraction in its most simple form. Getting a fraction in its most simplest form is the same as simplifying. Well, how can we get much simpler than this? The thing to spot is, does something occur in the numerator that also occurs in the denominator and therefore they cancel out? Well, in this fraction here, we have a b on the top and a b on the bottom. So this fraction can actually be written like this. b over b times by the rest of the fraction. Now we know that something divided by itself is just equal to 1. So these b's actually just simplify and they become 1. And this whole thing can then be written as minus 2 times by bracketed a plus 1 all over c times by bracketed b plus 1. We've gone from these three fractions and we'd written it as a single fraction here. But then we had to do one more step to get it into its simplest form, i.e. we needed to cancel out the b's. So here is the final answer. We have one fraction and it's in its simplest form. Let's have a look at a few more examples of simplifying. Example 1, we have 4a squared times by b all over 2ac. So the idea with simplifying fractions, i.e. getting them in the most simplest form, is looking for things that are in the numerator and also in the denominator, i.e. looking for things that can cancel out. The way I like to do that is kind of splitting up the fractions. So this fraction here I would write as the following. We've got the numbers in purple, we've got like terms in blue, and then everything else is just in black. This just becomes 2 and this just becomes a, because 4 divided by 2 is 2 and a squared divided by a is just a. I have a video on powers and roots, which if you don't understand the step that I've done here might help you. So we get the following. We can times all the numerators together and we can times all the denominators together to get the following. So this fraction here is the same as this fraction here, but this is in its simplest form. Let's look at example 2. Now with this example, you have to make use of your knowledge of factorizing quadratic. This expression here, the denominator, is a quadratic. When factorised, it becomes the following. Now from this, we can see that there's an x plus 1 at the top and an x plus 1 at the bottom. So we can write this fraction as the following. We've taken out the x plus 1s. This x plus 1 is here, and this x plus 1 is here, and then we're just timesing by everything else. Now we know that one thing divided by itself is just equal to 1. So this whole fraction just becomes 1. Therefore, we have 1 times by this fraction, which results in just this fraction. So here we go, which then becomes, this is so much nicer. This fraction is equal to this, but here it is in its most simplest form. Right, final example. This one looks like a beast, but it's totally fine. Again, we need to use our rules of factorizing quadratics. We also need to use our rules of just factorising general expressions. Let's look at this fraction first. The denominator is a quadratic. Well, we know how to factorise that into 2 brackets. The top is also a quadratic, so again that will factorise into 2 brackets. Now this fraction, again the denominator is a quadratic, so that will factorise into 2 brackets. The numerator isn't a quadratic, however it will factorise. We've got an x squared and an x, i.e. an x occurs in both terms, so we can still factorise this. So here we go. This is everything factorised. The next thing we can do is we can change that division sign. Let's change it to a multiplication by flipping round that last fraction. Now we can look for things that cancel out, i.e. things that occur in the numerator that also occur in the denominator. So for instance, we have x plus 3 in the denominator here, and we have x plus 3 in the numerator here. So them two can cancel out. Similarly, we have x minus 4 in the numerator here and x minus 4 in the denominator here. So they can cancel out. So our answer becomes this fraction here. Right, now is probably a good point to pause the video. Test your knowledge of algebraic fractions by answering these questions here. You can come back to the video and check your answers as well as your workings. Cheers!